All right, this is Advanced Math Lesson 1.4. I'm going to title this Complex Fractions. We're going to write down simplify, and if you remember, complex fractions are fractions within fractions. Don't forget you're writing questions as we go. All right, 7 over x plus 1 plus 3 over x minus 2 all over 4 over x minus 2, take away 3 over x plus 1. Now there are multiple ways of doing this. Some go a little quicker or a little faster than others, so I am going to show you the faster way. If you feel like I don't like that way, you can ask me about it in class tomorrow. The quicker way is to clear a complex fraction. And you clear complex fraction by multiplying everything by the common denominator. You multiply everything by the common denominator. And the one suggestion I have for us is making everything a fraction. That's already a fraction, fraction, fraction. If it's not, make it a fraction by putting a 1 underneath. All right, since everything's a fraction, I'm going to go ahead and clear. Now, I find the common denominator, and I'm hoping everybody can recognize that the common denominator is x plus 1, x minus 2. X plus 1, x minus 2. And I do that to everything. I'm going to erase that number 1 only because it's in my way for my notes. X plus 1, x minus 2, and x plus 1, x minus 2. Now you do not need to write it as a fraction. I do, so I just put it over 1 over 1. But technically, this is at the top, that's at the bottom. I just make them little itty-bitty fractions just so you can see there's a fraction there, a fraction there, a fraction there, and a fraction there. And as long as I'm doing it to every single term, I'm not changing the value, I'm just changing the way it looks. Okay, next step is to reduce. X plus 1 reduces, and you distribute your 7. And that leaves me with 7x minus 14. Plus, next thing here is I reduce the x minus 2, and then distribute your 3x plus 3, all over, and then here I'm going to reduce the x minus 2, distribute the 4. If you feel like I'm going too fast at any time, you can hit pause or rewind. 4x plus 4. And here I'm going to reduce the x plus 1, distribute, and I get negative 3x minus 6. And I purposely made a mistake here just to show you a common mistake kids make. When distributing and there's a minus sign, you have to keep in mind either you put parentheses here, or you remember that this is not a positive 3. Over here this was a positive 3, but this is a negative 3 that you're distributing. So when you distribute, it is negative 3x, but it should be a plus 6. And if you make that mistake on the test, unfortunately you will lose points. So make sure you are being careful with those negative signs. All right, combine. Oh, and if you've done this correctly, when you clear your complex fraction by doing this, this is how you clear a complex fraction. When you clear the complex fraction, your complex fraction should be gone. You should have no more fraction within a fraction. Every denominator should reduce, which did indeed happen. All right, so ready to combine like terms and reduce if possible. 7x, 3x is 10x. Negative 14, positive 3 is negative 11. 4x and negative 3x is 1x. Positive 4 and positive 6 is plus 10. Is there anything to reduce? No, I can't reduce these x's. I just cannot. I can factor or try to factor it since nothing factors. This is my final answer. All right, number 2. Number 2 is 2 over x all over 2 over x plus 1. All right, go ahead and write that problem down. Okay, so there's more than one way to think about this. Because this is a single fraction, not multiple fractions like this, because it's one fraction and one fraction, you are allowed to multiply by the reciprocal. So if you want to, I'm going to put a little thinking bubble over here. If you wanted to, you can do 2 over x times the reciprocal, because this is a division problem. You're multiplying by the reciprocal, so multiply by x plus 1 over 2. And you can see how that's going to be pretty easy. Cross out, x plus 1 over x, you are done. Or, if you didn't notice that, can you still do it the same way we did on number 1? Let's check. You clear a complex fraction by multiplying everything by a common denominator, and the common x, parentheses x plus 1. X parentheses x plus 1. These are not common. X is by itself, x plus 1 is by itself. They are separate, so this is your common denominator. All right, first one, does the x reduce? Yes, it does, and it should. Distribute the 2. Actually, I'm going to go ahead and distribute. 2x plus 2 over x plus 1 reduces. 2 times x is 2x equals. Now, if I stop here, is it wrong? Possibly, because I do have to factor to see if anything reduces. I can GCF this. 2x plus 1 over 2x. The 2's do reduce. And that leaves you with x plus 1 over x. Now you may be thinking, why in the heck would I do it this way? I wouldn't. Personally, I would do it this way. It's much quicker. You multiply reciprocal and you're done. I'm just showing you that the method I showed you on number 1 works for all of them. Would I have been able to do this quick way on number 1? No, because this is one fraction at the top, one fraction at the bottom. You're good. This has all these multiple separate fractions, so you have to do it differently. Either the quick way I gave you here, or common denominator, and then make it look like this, which does take a little longer. All right, number 3. X plus x over y all over negative y plus 1 over y. All right, x plus x over y all over negative y plus 1 over y. Okay, so remember what I said earlier about making everything a fraction first? You do want to make these fractions. Okay, so what you're going to do is make this by putting it over 1, so you can see that you have 4 individual fractions. You're better off if you do that from the get-go. And then you clear by multiplying everything by the common denominator. All right. What is the common denominator between all of these? It is y. I'm hoping everybody can see that. Okay, and then we're going to see if everything should reduce as far as the denominators go. This is over 1. Nothing cross reduces, but that is okay on that first one because y times x is xy. And 1 times 1 is 1. I don't need to put the 1 in the denominator. So it's okay on this one that nothing reduced because there's nothing left in the denominator other than 1. Plus reduce x Nothing reduces, but that's okay because there's only ones at the bottom. So that's negative y squared, and then reduce plus 1. Okay, now if you stop here, there is a possibility you might get it wrong because it looks like I can factor here, and factoring might allow me to reduce. So if I stop prematurely, then I might get it wrong. GCF. Now this doesn't look factorable. What if I write it like this? 1 minus y squared. Positive 1, negative y squared. Can you see that rewriting it allows me to factor? And you do have to do that come test day. Look at it and thoroughly say, can I factor or rewrite and factor? And if I rewrite, it is difference of 2 squares. 1 plus y, 1 minus y. And now we look to see if there's anything to reduce. And right here, these 2y plus 1 and 1 plus y are not opposites. They are exactly the same because it's positive. Positive y, positive y, positive 1, positive 1. They are not opposite. So I do not need to take a negative 1 when I reduce. It's just gone. I reduced it. All right, equals x in the numerator and 1 minus y in the denominator. And I just want to quickly talk about, again, like I said earlier, multiple choice, whether it's in my class or SATs, different test writers may write it differently. So is this the same thing? Negative x over y minus 1. And I only show you this because if you're taking a test, this might happen. You may end up with this, and the test writer writes this. Are the two things the same? They are. If I pull a negative 1 out here and put at the top, that makes that x negative. And pulling the negative 1 out here makes that negative y a positive y, that 1 a negative 1. They're opposites. So if I pull the opposite out or pull the negative out and put it at the top, they are the same. So you don't have to write it this way. You just have to know if you're taking a test and that happens, you don't freak out and think, oh, I've done something wrong. They are the same thing. All right, next one. 1 over x squared minus 1 over 25 all over x minus 5. Okay, complex fractions, fraction within fractions. Where kids struggle here is right here in the denominator. They leave it like this and they treat their common denominator as x minus 5 and then as the 25 and the x squared. The x minus 5 is not part of your common denominator. Do you remember what I said earlier about making everything a fraction? That's a fraction, that's a fraction, this is not. You have a choice. If you're writing in pen, just wait because I'm going to erase. You can write it like this, 2 separate fractions, as long as you make it a fraction, or you can write it as one big fraction. I'm going to write it like this, but totally up to you. Write it as one big fraction or x over 1 minus 5 over 1. Either way, you're going to get the same answer. Okay, everything's a fraction, and we clear by multiplying everything by the common denominator. And this is a 1, so that's not part of my common denominator. My common denominator is going to be 25x squared. 25x squared. 25x squared. 25x squared. Oh, sorry. Put an extra one there. I already had it on that side, so please excuse that mistake. Going too fast. All right, so we already have it taken care of right here, and this is one term. If you wrote them separately, if you did, then you would have the 225x squared, one on this side, one on this side. But since I wrote it as one, it's not necessary. Okay. So what ends up happening? The x squareds reduce. That leaves me with 25. Take away 25's reduce. That leaves me with x squared. Over. Instead of distributing, I can, but I'm going to leave it in factored form, and I'll show you why in just a second. So instead of distributing the 25x squared, which is typically something I would do, I'm not going to. I'm going to leave it in factored form. All right, I can see I have difference of 2 squares. 5 plus x, 5 minus x. All right, so what did I do here? I did square root of 25 is 5 times 5, square root of x squared is x times x, plus minus or minus plus. Now, why do I leave it in factored form? Right here, why did I not distribute? Distribute? I left it in factored form because I have to factor at the end to reduce anyway. So if you did distribute, let's just pretend you did, and you got 25 x to the third, and then you kept going, you're going to end up GCFing it anyway to get this. So it's better if you just leave it like this. It's okay if you didn't, it's just a suggestion. All right, is there anything to reduce? I'm hoping you recognize that these two are opposites, positive 5, negative 5, positive x, negative x. And what happens when you reduce an opposite? You take out a negative to the front. So that leaves me with negative parentheses 5 plus x over 25 x squared. Or some people write it this way, a negative in the middle, and then 5 plus x over 25x squared. That is the same thing. If you don't put it at the middle and you bring it to the top, you do need parentheses. Or distribute. Negative 5 minus x over 25x squared. All right, so any one of these is okay. You decide, leave it in parentheses with the negative at the top, drop the parentheses with the negative in the middle. You could even put it at the bottom or distribute the negative. I don't need you to write all of them. Just when you're taking a test, know they are all the same thing. I will never give you all three of these. I will give you one of them, and you just have to realize and recognize that they're all the same thing. All right, that's it for this lesson. Make sure you have questions ready for me for tomorrow.